If there are initially 2,000 bacteria in a culture and the number of bacteria double each hour, the number of bacteria after T hours, so T is the number of hours, can be found using the formula N equals 2,000 times 2 to the T power. So this will be our formula where T is the number of hours. So how many bacteria will be present after 5 hours? We're going to substitute that 5 as the T in the formula. N is equal to 2,000, and that's 2 times, and instead of T, we'll substitute that 5. So N then is equal to 2,000 times 2 to the 5th, which is 64,000 bacteria. Okay, how long will it take to grow 100,000 bacteria? So the number of bacteria, which is N, is 100,000. So we're going to substitute that 100,000 for N. We'll have 100,000 equals 2,000 times 2 to the T, and we want to solve for T to find the number of hours. So we'll start by dividing both sides by 2,000, and 50 then is equal to 2 to the T power. Then we're going to take the log base 2 of 50 and the log base 2 of 2 to the T power, and by the inverse property then we'll have our T equal to the log base 2 of 50, which is the log of 50 divided by the log of 2 using the change of base property. So we'll put that into the calculator, and the common log of 50 divided by the common log of 2 is approximately 5.6439, which would be approximately 5.6 hours. Okay, number 26, we want to solve the exponential equation and round our answer to 4 decimal places. So we'll start by dividing both sides by that coefficient of 2, and we'll have 4 to the x minus 5 is equal to 12. Then we'll take a log base 4 of both sides, and then by the inverse property that brings the x minus 5 down, and that's using the change of base property, equal to the log of 12 divided by the log of 4. Then we can add 5 to both sides, and x is equal to the log of 12 divided by the log of 4 plus 5. So when we evaluate that in the calculator, the log of 12 divided by the log of 4 plus 5 is approximately 6.7925. And we're going to store that as the x so that we can check the answer. So 2 times 4 raised to the x minus 5 power, and then is equal to 24, and we press enter and we get back a 1, which says that that checks. Okay, then in number 27 we'll go ahead and subtract 10 from both sides, and 3e to the 4x minus 5 power is equal to 6. Then we'll divide both sides by 3, that coefficient, and e is to the 4x minus 5 power, and that's equal to 6 divided by 3, which is 2. Then to undo a base of e, we take the natural log of both sides, and then 4x minus 5 is equal to the natural log of 2. Then we can solve for x by adding 5 to both sides and dividing through by 4. So x is equal to the natural log of 2 over 4 plus 5 over 4, which we can evaluate in the calculator. So natural log of 2 divided by 4 plus 5 divided by 4 is approximately 1.4233. And we'll substitute that into the original equation, storing the answer for x, and that's a 3e raised to the 4x minus 5 power plus 10 is equal to 16. And we press enter and we get a 1, and so we see that that answer checks. So then in number 28, we can rewrite this as a base of 2. So that would be a 2 to the 2 times 2x. Then 8 is 2 to the 3, and then x plus 1. And that's equal to, and we could rewrite 1 over 64 as 2 to the negative 6. Then using properties of exponents, we can add the exponents when we multiply the same base. So that would be a 2 to the 4x plus 3x plus 3. When we distribute over those parentheses, that's equal to 2 to the negative 6. Now that the bases are equal, we can use the one property to set the exponents equal. So 7x plus 3 is equal to negative 6. Then we can solve for x. So we'll subtract 3 from both sides, and 7x is equal to negative 9. Divide both sides by 7, and x is equal to negative 9 over 7. So we're going to store negative 9 over 7 as x in the calculator and then type the original equation to check. So 4 raised to the 2x power times 8 raised to the x plus 1 power, and then the equal sign and 1 over 64. We press enter, we get a 1, so we see that that checks.